So our next speaker is Antonia Almeida. Big round of applause, please.
So to start with a little bit of bad news. So I don't have we don't have internet here, so I cannot do the demo. Because right now what happens is that there's a Wi-Fi board. So this is only casino, and there's a Wi-Fi board, but the Wi-Fi is not working. This is a very old. So I don't know if you know this small architecture. You know this thing only casino. So it's manufactured by a Bulgarian company. It's completely open hardware. This is a pretty old version. It's around 2 years old. The question is if the thing that I'm using on it, which is the audio driver, don't work with the Linux mainline kernel. So you have to use this Linux Sun side project. And the idea is that this kernel is way behind the mainline kernel in terms of features. And so what happens is that you have to use this very old kernel, and I could not get, I didn't try even to install a new version, so it's really tricky. And so I could not make the Wi-Fi as a onboarded Wi-Fi to work, so I had to use internet. But unfortunately, we don't have internet here, so I cannot do the demo. So my name is Antonio Almeida. I'm now working as a developer for this company, Relayer. So my background is I came from web development, mostly backend development, and I've been working on this for more than a month. And for me, it's interesting when you are a web developer because what you see here in the Internet of Things is the extension of the things you already saw coming up in web development. So we know that now the systems are becoming more and more complex. We have distributed systems becoming everywhere, present everywhere. We are completely all around. And you see that the Internet of Things pushes that even further because now what you have is that not only do you have something that runs from the user and from the user to the cloud, something that runs on the cloud uses distributed systems, but when you have Internet of Things, you have multiple devices. Already, on the other hand, you also have distributed systems, so the things becomes more complex. For me as a developer, as a web developer, this is really interesting. So on the other hand, I'm also an audio geek. So in fact, the reason why I bought this computer was to make a streaming server for my wife, for my stereo. And the reason I didn't use a Pi is because the Pi at the time was only the 1A, and the USB implementation was kind of crappy, and so I wanted to interface the DAC with the USB. I wanted something that was good and not a bad USB implementation. So what I'm going to show you here is what you can do with just an idea you have on your head, and now you quickly you can prototype it, and you can really sidestep all these very complex things you have right now. So what I'm interested here is measuring noise. Okay, so I know if you work on open spaces, but this noise is a real issue, especially if you're a developer, because if you have other people that do other things, which is not development, you always have to have your headphones on. And this is not good for communication, right? If you're talking with people, you're supposed to be communicating with other people, but there's too much noise that you cannot focus. So noise sensing, I think, is a very important thing. So I think the IoT is really a misnomer. It's not the proper term, because it's not things. What you connect in really is APIs, okay? You have an API on the devices, you have an API from the bridging devices that connect to the cloud, and then from the cloud you have even more devices, more APIs. So, and I think also that there's been a focus on hardware, and the focus also on the sensor part. And the sensors are interesting, but what do they produce? They produce data, okay? And I think the big value is in data. And all the companies right now that are coming to this IoT thing, what they see is how can they use this data and save money or make more money using this data. And this is where I think free software plays a big role, because we already built the software. We just need to show these people, look, the software is here. We just need to know how to work with it and have ideas how to play with it. And that's what I'm doing here with this demo, which unfortunately I cannot show it. I even had a sound of an office, but there's no internet, so that's what we have. So I think that's been overhyped, this thing in Internet of Things. And people thought Internet of Things that was about your putting your fridge to tweet. I don't think it's interesting if your fridge tweets. I don't care what you have in your fridge. So I think this is Internet into junk. It's not the Internet of Things. So we as a company, we are interested in those things and you work with these games. So, like you see, this BSA, this Bosch sequence. For instance, Bosch, what they want, they have very old washing machines, and they want to know what's happening with the machines. You know, because you buy a washing machine, if it's a good quality, you're not going to buy a new one next year. So what they want to do is like retrofit something with this machine and then get data out of it. And with this data, they can then say, okay, your machine has a problem on the pump, you need to replace it. And then maybe they can provide to the client a proposal and say, why, instead of you replacing the pump, we can propose you a new one just for a little bit more. So it's interesting for the client and for the company. So when we started, this company, Relay, when it started, was basically a crowdfunded project, and they developed this thing, which is a starter kit. Anyone play with this? Wunderbar? Here? No. So it's a starter kit for the Internet of Things. So it has a master module, it has Wi-Fi, and then it has a bunch of sensors that connect with via Bluetooth. Okay? So you have an onboarding app that you run on your phone, and then you can have this thing. It has temperature, humidity, noise level, but noise level is not very good, just gives you an idea. It has luminosity, luminosity, and this is basically. And so they all have batteries, so you can cut all these modules and put them wherever you want, and they all communicate with the master module. So this is the dashboard when we have this solution, and you can onboard a device, and then you can manage your devices on this dashboard. So you use a lot of protocols, okay, in the Internet of Things, like the MQTT. This morning we talked about CoAP, HTTP, WebSockets, etc. Okay, and I was here in the first talk, and Peter said that MQTT is really not open because you cannot extend the protocol. It's true. It was initially a thing that IBM invented, and they saw, wow, this Internet of Things is coming up. Let's see if we can squeeze something in and ride the wave, right? Ride the tiger. So they open sourced the project, and now it's supposed to be an official standard, right? Completely open official standard. It's true. It's a very limited protocol. You only have PubSub. You cannot have request response. So you have to do kind of X on it. And what you do is, since you cannot extend it, you modify the payload, and you put the payload, and you can send commands, but then you don't have a response. So it's an interesting protocol because it's very lightweight. I think even if you work for this as a web developer, when I look at it, I see it's interesting for this microservice thing. Now that it's all the rage, sometimes people use very complicated solutions for queue, for synchronicity, and they could use MQTT instead, which is much simpler. It's already there. Just they're not aware of it because you just see HTTP and WebSockets, and you just look at it. You don't know these protocols. So the modern protocols are open and fully standardized, and we have APIs built on them. And I think the value comes from this data, like the washing machine. What you want to know is you as a client, as a user, as the owner of the machine, what the hell's going on with the machine, and the company that manufactures the machine wants to know also because they want to manufacture better machines and maybe try to sell a new one when they see that that one is starting to have problems. So, so I think also that IoT, the focus, what I have seen is mostly on hardware, okay, and they exclude everything else. But I think the most interesting thing is, I mean, the hardware is interesting for sure, and now it's really easy to get, and it's becoming a commodity. But what's really interesting is what you can do when you use that hardware and use free software. Okay? So all the APIs you can build that are there, that you can build and use to utilize that hardware and make all this chain from end to end, where you have the devices on one hand, and you have the data that you get to these devices, and then you can process this data and do many things with it. So hardware is just a tool. I'm using this. Some people prefer to use the Pi. You can use other things. You can use microcontrollers if you want. We'll build a noise sensing device that uses MQTT published to the cloud. Okay, the cloud. It's closed cloud, like it is Amazon cloud, but in fact it's built on free software. So there was a person here talking about Postgres. This pushes to a database, and the database that pushes is Cassandra, which is a completely open project, free software project. I think I didn't want to raise the issue when that discussion was, because I think there's, who knows here about the CAP theorem? Okay, so this gentleman was talking about Postgres. I didn't want to raise the issue about what happens when we have network partitions, how do they handle this thing, because this is between the data. So he overlook that aspect. And Cassandra was developed from the start thinking about this issue of every network, partitions, and distributed systems. So everything is open. In fact, although the cloud is closed, everything is built on open source. It's Cassandra for the database, for the web store. It's Mosca for the MQTT, which is an Node.js implementation of an MQTT broker. And the HTTP API is built on Scala. So everything, although I'm pushing to this cloud, everything is, you can build it your own if you want, okay? So I think noise is very important. It's a health issue. And also I think that more and more silence is becoming a rare thing. So we have pipe music everywhere. We have the noise in the cities. So it's really important for you to assess it's a health issue. I think it's a health issue. And it's also a question of you being more productive, being happier in your work. If you have a noisy environment, you're not happy. You always feel stressed and you don't want to be here. And you wake up in the morning and say, I'm going to go there and be there, and fed up being to put up with all this noise, all these people chatting, and you start hating your coworkers because they shout or they laugh very loud all the time. So I think this is really a very important issue. So this is like it. So I think in the 18th century they had much less noise than they have now. So this is all you've seen of A13. Unfortunately, I cannot do the demo. So this is basically an ARM computer. Uses an ARM Cortex A8 ARM core. That's what it uses CPU. And then it has, I think the big thing, and this is what Jenkins advantages here. It has an audio codec, which means it's an audio input and output. It is microphone input, and you can run Linux in it. And you run Linux in it, you just use ALSA, and with ALSA, which is a free software project, you can capture sound. You put a microphone and you capture sound. And this is the whole idea of this prototyping. It's like using only what you really have, and try to do something which is really useful, like noise sensing, with just standard components. Because they are, of course, professional things for measuring noise, but they are really, really expensive. So the demo, unfortunately, I had to skip it. So there are, I can show it here on the terminal. I can show the code running on the terminal here, but it's not as interesting as there, and I'll do that. So what you're going to see here is just a start. Of course, it just built with a bunch of shell scripts. It just used the Mosquito clients, okay, the bud sub clients from Mosquito, which is a reference implementation for MQTT as a broker and as clients. But you can go further. Just with this thing, you'll have already something which is really useful. And you can go further, and if you want to have, so the microphone that I have here for the demo, it's like an omnidirectional microphone, so it means it captures sound from all directions. But you could have like directional microphones and have a microphone array, and you can have a multiplexer that goes to those microphones, and you can do sampling on the room or in the big room. You can do a sampling and know exactly what's going on in each location, and not have cross-talking or interference between the noise that comes from one location to the other. So let's see if I do the demo here. Okay, so does everyone see this, or do you want the font to be bigger? Everything okay? Bigger? Okay.
Probably use Control Plus.
Yeah, but I'm not sure it works on this terminal.
Okay.
This is not the problem. Better? Okay. So what I have here is just two scripts. The project is on GitHub. I'll show you this. The project is on GitHub. What I have is two scripts. It's one script that publishes to the Relay Cloud, and I'll show you here this working. And you have a script that just subscribes to this topic. So MQTT, everyone here is familiar with MQTT. We talk MQTT topics and all that. So it works with topics. You publish according to a topic. In this topic can define a hierarchy of topics, like you have your house, and you have your temperature in your house, the humidity in your house. So you can say /house or /home, and then you can say /home temperature, /home humidity, /home luminosity, things like this. Here I'm just using a very simple, just one topic without any hierarchy. In fact, there's kind of a hierarchy, but it's inside, it's in the payload. And you see this, there's this thing that called path, all right? But they're called path, and it's the path. It's called path just because we had to find a name that was not prone to confusion when you have different devices. This was when you develop a project for a fridge. But it's not directly related to this MQTT topic path. And so this published this topic. So MQTT can have like semantic, and this means like this is the MQTT topic. So this is the API version v1, and this is the topic. As you see, it's just a UUID. It's a 128 byte unique number. Okay. And what happens is this this thing here doesn't have any meaning. It's just a way for you to associate a physical or a logical device with with the topic, nothing more. So I'm going to do here, and you will see this. So how does this work? So this uses socks. This uses socks. So socks, everyone here knows socks. Like it's a kind of a Swiss tool for working with sound. You can do a lot of things with it. So it uses socks. It does a sample of a sound at once, a second long sample. I'm just interested in here in things that affect humans, and this means that the sampling frequency is off. It's just 22 kilohertz. Okay, I'm not using like the CV specification because I don't. It's not about hi-fi. It's about I'm interested to know what sound affects humans, and you know that about it's something around the 3 kilohertz. So I'm cutting this on the 10 kilohertz. So this is what I did. So we published this. It's sent. And then we have here the data. So there's three things that are sent on this payload. So is the path, which is the RMS value, and this is a relative value. Okay, this is represented as a 32-bit sign inside. Okay. So this is a relative value of the amplitude, so the meaning is a number. This has to do with the specification in terms of the way you have a widget. I'll show you this. And then because this is an RMS value, this is a mean value, and this is a rough estimate of the frequency. Okay, of the frequency that the microphone display is the microphone from the button. Okay, now I could see here if I want. I could have here subscription. Okay, see here, publish it in. Yeah, so you get this thing here, and you receive the value here. So if I want to show you so this is the thing I'm using here for this for the demo that unfortunately I won't be able to do. I can do this demo if you find me an Ethernet cable. I can show this working for you. So this is the device I'm using. So this is a small ARM computer. So what I've shown here, this was done with a very crappy microphone. I can show you. This is just from some cheap headphones. This is not even a high quality microphone, but this is enough for you to get an idea. Okay. But if you want to be really serious, you can use like a professional microphone. Like you have this thing here. It costs around like $80. It's an American thing. This is a professional microphone. This is calibrated, which means that the values that you have relative. Then you can, when you calibrate it, then you can have a meaning in terms of dBs, SPL, and sound pressure. So other things, yes. So the code is here. It's on GitHub. It's just a bunch of shell scripts. Yeah, this is what we have here. So this is the publish. This is what it is. It's very simple. Just uses Mosquito. Publish uses JQ. It's like a JSON parser on the command line, just to show you the payload master. Yeah, and it has a bunch. Just it's a very simple thing, and the subscribe is even simpler. So this is just an idea. Unfortunately, I cannot do the demo. What you can do with just free software using the APIs this free software provides, and I mean the sky is the limit. This is just an idea about sound sensing, and it's a really important problem. And most solutions out there are really too complex, I think, because they are focused towards hardware, use like analog to digital converters. But you already have an analog to digital converter if your device has an audio codec on it. So you can use that and start playing with it. You can even use, if you want to do acoustic measurements, you can use this also to do acoustic measurements if you want. So unfortunately, can do the demo, so that's it. Any questions? Yes?
Yeah, I think your comment about send the referee, the information for your referee to your to the Twitter. I mean, I agree this is not a very good use case, but I think this is a proof of concept that you can, connect the thing, the constraint device to web services. But unfortunately, these days, because the reason we chose like a social media like Twitter or Facebook, because they actually provide you interface to do your apps. I mean, ideal situation, like for one example, is like if I send my heart rate information to my my health carer's web server. But unfortunately, you at this moment it's very hard to have such a server support.
Yes.
So,
Yes. Yes, this is a good point. I think that the reason why they use social media, because I think they use it just as a marketing device, because it's like it gets marketing, it gets interest, it gets clicks. I think it was just this. Frankly, I don't see any interest about in sending tweets, sending your fridge contents to Twitter. On the other hand, if you can tell if the fridge has a problem, I think this is really useful. It's really useful for you as the owner of the fridge, and it's really useful for you as the manufacturer of the fridge. I just think it was just a marketing thing, and it got a lot of bad press for IoT because there are a lot of security issues with it.
that's right. I mean,
I'm sorry, I think we have to cut this now.
Okay.
It's 25